Good morning. My name is Laura De Giorgi, and in this presentation I will resume my first achievements in my first year of my PhD. The goal of my PhD is to optimize an application, in particular starting from a machine learning model that predicts the execution time of the duration of the run. We will start from that to optimize the application, to reorganize job, and to perform dynamic resource allocation. In particular, this is the structure of the application that we take into analysis. In particular, it consists in 3 different phases, each one performed on different VM, and in particular, each phase, the application is run on different queues, each one with a different architecture. The 2 main phases are the loss simulation phase, where many risk factor and loss function are evaluated on these scenarios, and then the aggregation phase, where different financial reports are generated based on the risk factor and on the scenarios generated. So in the aggregation phase, a variable number of outputs can be generated, so this is the most difficult problem to be handled. In particular, we consider the data set that contains historical records of the application from September 2022 and February 2024. Since this data set, since the application can require a valuable number of outputs, before we decided to limit the maximum number of outputs, namely we limited our analysis to a maximum of 60 reports required, and then with a maximum run duration of 700 seconds, because for higher durations we had few data. To evaluate the model, we considered the mean absolute percentage error, and all the experiments were performed dividing our data set into training set comprising the 80% of the data and the remaining 20% for the test set. We started in an incremental manner, starting from the case with 1 report required, then we moved on the case where the run that requires up to 5 reports, and in the end, with the run that requires up to 60 reports, performing model ensembling. Our results were the one reported on the table, namely for the worst case, for the case up to 60 reports, we get an error in the testing phase of more or less 17%. These are results for the 1 report case. In particular, we have reported the duration of the run compared with respect to the predicted execution time. And what we can see is that the model has a more good predictive capabilities for lower durations, and so we reported also the mean absolute percentage error per time interval to verify whether the error were uniformly distributed in all the time frames. Then we passed to the case up to 5 reports, so we duplicated in our data set, we duplicated the features associated to the report. In particular, our dataset contains 2 types of features: the fixed features, that are the one that are related to the first phases of the application, and then the features associated to the report. So we repeated the features of the report as many times as the report were required. And so we showed more or less the same plot. Also in this case, there is a higher error for longer runs. And then we moved on the case where up to 60 reports were required. In this case, we performed model ensembling, considering partial forecasting for a group of up to 5 reports, and then we reunified all this forecasting to get our final result. For all the cases, we used XGBoost as a predictive model, and in the end, we also used XGBoost for the final forecasting. And in this case, we get more or less the same behavior with a higher error for longer runs. Our model, as a conclusion, we can say that our model effectively estimates run durations, but we encountered some challenges with the longer runs and the variability of the number of required reports, and we are exploring other techniques to improve the predictions and also to integrate this prediction to implement the scheduling policies to reduce user waiting times. So I thank you for attention.